Welcome back. Today's the day to learn about acids and bases, and in particular we're going to learn about concentration versus strength and how do they relate. So we're in your notes. We're just after the section on amphiprotic substances, and there's also a video for you to watch on that when we're done. But this is just a little short video about concentration versus dilute, or concentrated versus dilute, and then strong versus weak acids. So we've talked a little bit about concentrated versus dilute before, so hopefully this is just a little bit of a revision. So it says in your notes that concentration refers to the amount of solute in a given volume of water. For example, a large amount of solute, so the solute particles are these blue ones, a large amount of solute in a small amount of solvent will give you a concentrated solution. So that's this one here is a concentrated solution. Alternatively, if you have lots and lots of solvent, not much solute, that gives you a dilute solution. So you can see here that there's not as much solute there. You can see it really obviously with things like cordial. So concentrated acids, though, if we're going to talk about how concentrated an acid is, you need to say that it has a high number of mole, per volume of solvent. Whereas dilute will have a low number of mole per given volume. And that's all we need to know about concentrated versus dilute. The next bit gets a little bit trickier. So we're going to talk about these things called strong acids. So just because an acid is concentrated doesn't mean that it's necessarily strong. So strength of the acid refers to its ability to donate a H+ ion to a base. So things that readily give away their H+ ions are considered strong acids. Things that don't readily donate their H+ ions, they are considered weak acids. So the strength of an acid refers to its ability to donate the hydrogen plus ion to a base, or the proportion of acid molecules that react with the water to make hydronium ions. So the process of donating a H+ to a base is called ionization. A strong base can readily accept the H+ ions from an acid. And here is an example of a strong base. Strong acid. I just got a little bit confused with the dog going on, but that's all right. So this reaction, the dissociation of nitric acid with water, occurs to almost 99% completion. So it's a very strong acid because it has this ability to just dissociate and give away its hydrogen ions. The most common strong acids that we deal with are HCl, HNO3, and H2SO4, sulfuric acid. So those three acids are what we consider strong acids because they readily donate their H+ ions. A weak acid, though, is where very few of its molecules give up their hydronium or their hydrogen ions. So, for example, this one here, and I'm hoping that you're pausing and thinking, what is this acid? This one here is ethanoic or acetic acid. It's the one that you find in vinegar. You wouldn't expect that to be very strong. Vinegar you can eat. And this one only happens to about 1 to 5% completion. Okay, and so as a result, we call that a weak acid. So the equation suggests that even if there are enough water particles present, there will be quite a lot of them that stay here. So almost all of these become this, almost all. But in this one, only a few become the ethanoate ion. So having a look at that, a low proportion of H3O+ molecules will be produced. Hence, an acid can be defined as weak, like the bottom one, or strong, depending on how easily it ionizes or how easily it donates its proton. All right, here's the memory time. These are all the acids that you need to commit to memory. If you need to put them down in a list somewhere, I think they're in, yes, they are in your notes. But if you need to be making a flashcard on them, these are the ones that you need to be able to remember. So your strong acids are your HCl, H2SO4, and nitric acid. Then you've got some weak acids like ethanoic acid, because that's in vinegar. So any of the ones we kind of eat are pretty good. Carbonic acid, that's in soft drink. Now, so the acid that's in this here is going to be carbonic acid, which means that it can mildly irritate your teeth. But if you were to eat hydrochloric acid, it's definitely going to eat away at your teeth. And then phosphoric acid, which is in some foods, but in particular, that's not too much of an issue. Then you have strong bases. And so these are ones that readily accept the protons. And therefore, we've got the ones that are the conjugate bases to a strong acid. So if you've got so here's nitric acid down here, you would have that its conjugate base over here, which would be NO3 minus, would be weak. So that's a weak base. So essentially, you can't be a strong acid and a strong base. You have to be one or the other. So to define an acidic solution, we can look at a couple of things. So this is right down the bottom. Sorry, I'm just going to finish off the notes just down the bottom of the page, just before the box that says 15.2. It says, as HCl is a strong acid, it completely donates its H plus ions to a base. And the conjugate base, Cl minus, so this is HCl, is your acid. Your conjugate base is Cl minus. Cl minus, so this would be a strong acid, and this is a weak base. Yeah. So if you've got a strong acid, it's going to have a weak base. On the contrary, though, we've got things like ethanoic acid, CH3OOH is the acid. It is weak acid, and its conjugated base is CH3OO minus, and it is a strong base. The ethanoate ion that forms there is really easily just going to accept a H plus to make it complete. So overall, the stronger your acid, the weaker your conjugate base. Now I'm just going to go up to the top of your notes. I seem to have done these things just a little bit switched around. So as to define an acidic solution, you need to look at two things. You need to look, is it concentrated or dilute, and whether or not it is strong or weak. So they are independent of each other. You could be a concentrated strong acid or a concentrated weak acid. You could be a concentrated strong base or a concentrated weak base. Or you could be a diluted weak base or a diluted strong base. It doesn't matter, so long as you understand that the strength is not changing depending upon the concentration. So acids will either fall into the strong or weak category, always, and they always stay in that category, as their ability to remove or their ability to ionize remains the same throughout. However, depending on how much acid you add to the solution, you could have a weak acid could be concentrated. So you could have a concentrated weak acid like vinegar, then you could dilute it out with water and you would have a dilute weak acid. So similarly, your strong acids can be made up as dilute or concentrated solutions. And that is the end of the difference between concentrated and dilute and strong and weak acids and bases.